Okay, I want you guys to have another example of a proof, and I want one that's kind of big and has some interesting twists and turns to it. So let's try this one out. We are given that angle QRS and angle PSR are supplementary. We are asked to prove that angle QRL is congruent to angle PSR. And by the way, I would love it when you guys are looking at these problems, if you're either saying out loud what you're looking at or you're thinking it to yourself, so that you're not just looking at concepts that you're not even sure how to. If you can't say it, it's certainly going to be hard to understand it. Okay, here's the diagram that these guys are based on, and let's take a look and see what we can do. We're going to start off with a statement that angle QRS and angle PSR are supplementary. And we know why. Big old G. Given. Oh, by the way, I'm going to give myself a little more space. I already know in advance I'm going to need to do some writing here. So, the next thing is, and by the way, given is easy to write. Hopefully every one of you writes down given, whatever's given right at the start. What's always tricky with proofs is where do you begin? So, other than the given, where do we begin? Well, let's take a look. We know that we're trying to prove something related to PSR, and we're already told something about PSR. We're given something about PSR right at the beginning. We'd like to know something about QRL, and we're told something about QRS. And I'm just trying to give you my thought process here. So what I see is QRS in the diagram and QRL in the diagram. They're right next to each other. They're adjacent angles. And not only that, the two angles add up to a line, which makes them a linear pair. So I am going to be so bold as to say that the measure of angle QRL plus the measure of angle PSR, I'm going to say those two add up to 180 degrees. Now, I'm probably skipping a step here, but if you were to do this, I would be lenient on you because of that. I'm going to say that this has to do with the definition of a linear pair, and probably there's some sneaky math people out there that would break this down into more steps. For instance, we could say something like this could be, we could actually say step 2, angle QRS and QRL are they make up a linear pair, definition of linear pairs. We could then say step 3 that they are supplementary, angle QRL and angle PSR are supplementary, again definition of linear pair. And then finally we could say measure of angle QRL plus measure of angle PSR is equal to 180 because definition of supplementary angles. But I'm going to do it all in one, put it right here, definition of linear pair, and if you do that, I'd be with you. Okay, next, step 3. Now, we now have a way of relating QRS and PSR, and QRL and, oh, I screwed up here. For those of you who are wondering what the heck's going on, it's not QRL plus PSR that are 180. It's QRL and QRS. So I screwed up. Sorry about that. For those of you that are freaking out, let's fix that. Let's see here. Okay, so that's better. So measure of angle QRL plus measure of angle QRS equals 180. Sorry about that. I was saying something and thinking something different than what I was saying. So here we go. So let's see here. So QRL and QRS definitely add up to 180 because definition of linear pair. Now we can relate. And by the way, I want to point out that I recognized I made a mistake because I was trying to put this stuff back together with the other stuff that I knew, and I could see something didn't make sense here. I now can relate QRS and PSR, and I now can relate QRL and QRS. So now I'm getting closer and closer to relating the QRL and PSR. So let's see what we can do next. Because, let's see here, because these two are supplementary, I'm going to say that the measure of angle PSR plus the measure of angle QRS. When you add those, they should be equal to 180. Why is that? Well, it's because we said QRS and PSR are supplementary. Boom. So definition of supplementary. I told you guys this would have a lot of interesting twists and turns. So far, pretty good in my estimation. Next. What can we do next? Well, since these two are equal to 180 and these two are equal to 180, we could just say that these two must be equal to these two. And that could either be substitution or transitive property. So I'm going to go ahead and try to write this as best I can. Measure of angle QRL plus measure of angle QRS should be equal to, I don't have a lot of space, so I'm just going to put it here, equal to the measure of angle PSR plus the measure of angle QRS. And we can say either substitution or transitive. I would accept either one on a test. I'll write them both for you to consider. And then step 5. Now, by the way, again, this would be an excellent proof for you to try on another day. You go back and you run the video, you look at the thing, you try to do the proof yourself, and then you hit pause and you try to do the proof yourself, and then you watch me and you see if we agree. Anyways, let's do step 5. Now, step 5, I am going to give you a minute just to consider. I was really kind of greedy by telling you substitution and transitive property for this one, for 4. Hit pause and see if you can figure out what the next step, what the next statement is, and the reason why, based on statement 4. Okay, I'm assuming you hit pause and you gave it the good old school try. Anyways, here we go. So, what I'm going to say is this. Notice that on both sides of the equal sign I have measure of angle QRS. And I want to point out that measure of angle QRS is simply a number. So, turns out we can do math with numbers. And in this case, if I was to subtract this guy and this guy, I would end up with measure of angle QRL equals measure of angle PSR. So, I'm going to do it. Let's try. We're going to go measure of angle QRL equals measure of angle PSR, and that is because of what property? Did you already guess what property? The subtraction property of equality. It's kind of interesting that this pops up even in geometry, but it does. Subtraction prop of equality. And remember, that is an algebraic property, and nevertheless we can use it here in our reasons. Okay, so I think we're getting pretty close. We want to prove that angle QRL is congruent to angle PSR, and this just ain't bad. Now, it turns out that there is another step where we can say angle QRL is congruent to angle PSR, and it has to do with, I think we have a postulate that says that, that congruent angles have the same measure, and so I'm going to look it up just to be sure, and then I'm going to share it with you. Okay, I really had to do some digging to figure this one out. I like the idea that, you know, you and I need to go back through either our notes or the student journal or the textbook in order to find the definitions that we need to make sure that we're stating them correctly in the proof. And in this case, it turns out I found on page 40 of the textbook, and maybe you might want to write that down, that is the place where we have this. And what this is the definition of congruent angles. It says two angles are congruent when they have the same measure. Now, again, that's page 40 in the textbook. I'm just going to write it over here. Maybe you might want to add that to your notes. Definition of congruent angles. In the meantime, I'm going to use it to finish off this proof. I wanted to figure out that angle QRL, I wanted to find out if angle QRL, I wanted to prove that angle QRL is congruent to angle PSR, and I am at that point, and it's because definition of congruent angles. Now, Again, definition of congruent angles, when two angles are congruent when they have the same measure. Angle QRL, the measure of angle QRL is equal to the measure of angle PSR. Therefore, these two angles must be congruent. Yay! Woo! We're done.